Hello everyone, in this video we will see the implementation of F1 of ABC is equal to sigma M1457 and F2 is equal to pi M2367, that is SOP and POS form using decoder with active low output. So there are three variables at the input, so we can implement this using a 3/8 decoder, and the decoder output is active low, so we have to consider that also. So let us first draw the truth table corresponding to this. So ABC are the input variables and F1 and F2 are the output variables. So the first function is F1. F1 is in the SOP form. So 1457 are the minterms. So corresponding to the minterms we have to mark 1s and the others will be 0s. So 1 is corresponding to 1, it is 1. Then 4 is 1, 5, 1, 7 is 1. The rest will be 0s. Now next is F2. F2 of ABC is pi M2367. So this is the POS form. So these are the max terms. Corresponding to the max terms it will be 0s and the rest will be 1s. So corresponding to 2 we can write 0, 3 it is 0, 6 and 7 also 0 and the rest will be 1s. Now we can move on to the implementation part. So let us take a 3/8 decoder. So let this be a 3/8 decoder. So it is having three inputs A, B and C, and the outputs are, it is active low. See, we have to show a bubble over here. So this is D0, D1, D2, D3, D4, D5, D6 and D7. So the first expression is sigma M1457. So let us take the output corresponding to 1, 4 and 5 and 7. So 1, 4, 5 and 7. So corresponding to 1, 4, 5 and 7, the output is high. So we must get a high at the output. So we have to connect a gate such that the output should be high and the input of that gate will be low, because the output of the decoder is active low. So if it is 1457, so if 1 comes at the input, correspondingly D1 will be low, and but we must get a high at the output of the logic gate because it is a SOP form. So corresponding to 1 we should get a high at the output, but the output of the decoder is active low, so we will get a low at the output of the decoder. We have to convert that to high. So we have to use a gate such that the output of the gate will be high when any of the input is low. So we can use a NAND gate for that. So as you all know, the truth table of AND gate is like this. So if any of the input is low, the output will be high. So we can implement the SOP function using this NAND gate. Now next is the POS function. POS function is pi M2367. So if 2 comes at the input, then D2 will be low, and correspondingly we must get a low at the output also. 2367 is the product of some form. Product of some form is pi M of 2367. So if we give 2 over here, since it is active low, we will get a low over here. So at the we should give it to a gate such that at the output of the gate also we must get a 0, since it is in the POS form. So we are going to connect 2, 3, 6 and 7 to a logic gate such that its output should be low when any of the input is low. Means we can implement this using a AND gate. So the AND gate is like this. If the input is 0, 0, the output is 0, 0, 1, 0, 1, 0, 0 and 1, 1, it is high. So if any of the input is low, then the output will be low. So we can implement that using a AND gate. So we will get F1 over here and F2 over here. So we can implement the SOP function with decoder output active low using a NAND gate, and we can implement the POS function with decoder output active low using a AND gate. So let us consider one sequence at the input. So let us consider 2 at the input. So if we give 2 at the input, then D2 will be low, as we have written over here, D2 will be low and all other inputs will be high. So all the inputs of this AND gate is, NAND gate is high, it will be high over here, and so F1 will be equal to 0, and since D2 is low, one of the inputs of the AND gate is low, so the output of the AND gate will be equal to 0. So F1 will be equal to 0, F2 will be equal to 0, corresponding to 0, 1, 0. Let us verify this in the truth table. So corresponding to 0, 1, 0, F1 is 0 and F2 is 0. Now let us consider 1, 0, 1. That is 5. So 1, 0, 1. So correspondingly 5 will be low, D5 will be low and all other inputs will be high. So here corresponding to this D5 will be low and all other inputs will be high. So this input has gone low. If any of the input of NAND gate is low, then the output will be high. So the output of the NAND gate will be high, and here all the outputs of the AND gate will be high because D5 is not coming to this AND gate. So all the other outputs of this decoder except D5 will be high. So the input of this AND gate will be high, and so the output will be F2 will be equal to high. F2 will be equal to high. So corresponding to 1, 0, 1, F1 will be 1 and F2 will be 1. So corresponding to 1, 0, 1, F1 is 1 and F2 is 1. So we have verified the functions also. So this is the SOP and POS implementations using decoder circuit with the decoder output as active low. If we want to implement the same function using a decoder with active high output, then we can implement this SOP function using an OR gate and POS function using a NOR gate. So we have discussed about this in previous video. So that's all for this video. Thank you.